Hi everyone. Today we are going to discuss about expansion by using method of substitution. Now let me start. So when we think about expansion of a function, that is you have must know Taylor series expansion and Maclaurin series expansion, guys. Means in expansion of functions there should know little bit knowledge about Taylor series and Maclaurin series. Taylor series and Maclaurin's series. So for these series, we have to expand any series in powers of x or in powers of x minus a, guys. So let's see. There is a type of expansion by using method of substitution. So in this concept, there are some additional results are required, guys. By using suitable substitution in a function can be reduced. By using a suitable substitution of a given function can be reduced to standard form of function, and we'll have to solve by using Taylor's or by using Maclaurin's series. So for that, first of all, you see there are some additional standard results. So I am writing here some standard results are there. Some standard results we have to use here. So which are the standard result? Number one, sine inverse x. Sine inverse x, there is a trigonometric, that is inverse function, and you have to write the series expansion of this or you have to use the series expansion of this sine inverse x. So that will becomes, that is x plus 1 by 2 into here x cube divided by 3 plus 1 by 2 into 3 by 4 here, that is x raised to 5 divided by here 5, means plus and so on. You have to use the standard result in series expansion of method of substitution. Also there is a second result which is important one, that is a cos inverse of x, and you know the formula for cos inverse of x, that is a pi by 2 minus in bracket x plus here 1 into, means I am writing here 1 divided by 2 into x cube divided by 3 plus 1 by 2 into 3 by 4 into x raised to 5 divided by here 5, means this is nothing but cos inverse of x equal to pi by 2 minus sine inverse of x, guys. Pi by 2 minus sine inverse of x, and we have to take plus and so on, it will get infinite series is there. Also third formula for tan inverse x, guys. Tan inverse x. So tan inverse x is nothing but, that is x minus, that is x cube divided by here 3 plus x raised to 5 divided by 5 minus x raised to 7 upon 7 plus and so on. So these are the inverse formulae of, means these are the trigonometric inverse formulae and their expansions, guys. Also you know about the number 4, that is hyperbolic functions, right? Means hyperbolic inverse function. Also we are required here hyperbolic function, and it's a inverse hyperbolic function. So I am taking the next formula for sine inverse hyperbolic x, so that is called as inverse hyperbolic function. So this can be written as now in this way, that is a sine h inverse of x, means what is that here, sine h inverse of x, that is inverse hyperbolic function. That is a little bit something change in sine inverse x formula, guys. So this is a x minus 1 divided by 2 into x cube divided by 3. Now plus or minus alternate is there, so next term will be plus 1 by 2 into 3 by 4 into x raised to 5 upon here 5. Next term will be minus and here so on. This is sine hyperbolic x. And number 5 formula you have to use, that is a tan hyperbolic, means tan inverse hyperbolic x, and that is equal to, that is x plus x cube upon 3 plus x raised to 5 upon 5 minus, means there will all terms are plus is there, x raised to 7 upon 7 plus and so on. So there is a little bit change in tan inverse of x and tan h inverse of x, guys, and you have to use this result by method of substitution. So first of all, in method of substitution you have to follow some steps is there. So what is a working rule? Working rule for method of substitution of expansion of function. So these are the working rule you have to use here, guys. These are the working rule you have to use here. So let's see. First you have to just write the given equation as, means I am writing, let given function is f of x, guys. Let given function is f of x you have to write. After that, number second, you have to just follow the substitution. Means your sin x, your sin theta, your cos theta. So you have to substitute a parameter, guys. You have to substitute a parameter. Means substitute for value of x. Substitute for x is equal to here sin theta, sin hyperbolic theta. Means I am writing here x is equal to sin theta. Means the requirement of example is there, sin hyperbolic theta. Also we have to replace as x as tan theta, x as cos theta, x as tan hyperbolic theta. Means you have to substitute for x, and you know x means that is series expansion of sin hyperbolic theta, cos hyperbolic theta in this way. And after that you have to just write the series expansion of above result. So number 3, write series expansion of x, that is expansion of sin theta, cos theta, tan theta, and you will have to obtain the required series. Number 4, obtain required series. Obtain here required series. So we have to follow these rules, guys. You have to follow these rules. So for example, let me start. Suppose an expansion is given to you and you have to solve the method of substitution, guys. So let's see. For example, I have to expand here. Expand. Suppose sec inverse of 1 upon 1 minus 2x square. 1 minus 2x square. So how it will be expand, guys? Let's see. That is very easy. First of all, you have to write here what is the sec inverse of here 1 upon 1 minus 2x square. So therefore, let sec inverse of 1 upon 1 minus 2x square is given here. So put in this equation by observing the first step, that is a given. So put here is a sec inverse, guys. Here is a sec inverse. So for that, you know, I have to put here x is equal to here sin theta. I have to put here x is equal to sin theta. So therefore 1 minus 2x square, that will becomes here, means denominator you check 1 minus 2x square. So I am writing for that 1 minus 2x square is equal to 1 minus 2 sin square theta. 2 sin square theta. X is replaced as a sin theta, so that becomes 2 sin square theta. So 1 minus 2 sin square theta, there is a formula, and formula becomes it is what? Cos 2 theta. Formula becomes it is what? Cos 2 theta. So in given example, what is that? Sec and cos, these are the reciprocal of each other. That's why I am converting x as a sin theta, and it will get denominator as cos 2 theta, guys. Cos 2 theta. So therefore sec inverse of 1 upon 1 minus 2x square can be written as, this is a sec inverse of 1 upon, you know, for denominator 1 minus 2x square, that is, it is nothing but cos of 2 theta. Cos of 2 theta. So you know, again, after I am simplifying this, what we will get here? 1 upon cos 2 theta, it is nothing but it is a sec of 2 theta. because of that you see here, cos theta, it is nothing but 1 upon sec theta. So that implies sec theta, it is nothing but 1 upon cos theta. So for just reason, I have to write sec inverse of sec 2 theta is now in this here. Means instead of this 1 upon cos 2 theta, I have to write here sec of 2 theta, guys. So therefore, you know again very well, that is a sec inverse of sec 2 theta. It is nothing but sec inverse and sec inverse and sec. It is nothing but here only 2 theta. And you know guys, what is a 2 theta? Theta means here, if x is equal to here sine theta, so that implies theta means sine inverse x is there. So therefore I am to writing here, that is theta means here 2 into sine inverse x is there, 2 into sine inverse x. So because of that, since I already substitute here, x is what, sine theta, so that implies theta is equal to what is that here, sine inverse x. That is, we get here trigonometric inverse function is there, right? And you know the sine inverse x series is what, you know the sine inverse x series. So let's see guys, I'm writing here sine inverse x is series now in this way, that is x plus 1 by 2 x cube upon 3 now in this way. So let's see, so your answer will becomes here 2 into sine inverse x. So therefore this is equal to, means a sec inverse of 1 upon 1 minus 2x square, that is nothing but it is a 2 in bracket, what is sine inverse x? Sine inverse x is x plus 1 by 2 into x cube divided by 3 plus 1 by 2 into 3 by 4 into x raised to 5 divided by 5 plus and so on. So this is required answer of given example, guys. So in this way we have to just solve by method of substitution. We have to substitute, means we have to put here x is equal to what, sine theta, and after that you have to getting the required series expansion. So let's see, I'm taking another example for finding method of substitution. So for example, I am going to discuss here, that is expand tan inverse of p minus qx upon q plus px. So how it will be expanded? So now we have tan inverse of p minus qx, that can be written as, let, I am considering the answer is here, let tan inverse of, that is p minus qx divided by q plus px can be written as, this is a tan inverse of, I am writing now this in this way, p upon q minus x divided by here 1 plus p by q into x. Now for simplification you have to understand this, that is the adjustment of numerator and denominator is there. Now we put p by q is a tan alpha. Now I am substitute, or here I am writing substitute, p by q is equal to, there is a trigonometric function that is a tan alpha, and x is equal to here tan theta. So after taking this substitution, therefore your tan inverse of p minus qx divided by here q plus px can be written as, this is a tan inverse of, what is that here, p upon q is what is that, there is a tan alpha, minus x is what is that, tan theta, right, divided by 1 plus p by qx. So I am writing this 1 plus p by q, means again here tan, what is that here, alpha into tan theta, and this is nothing but this is a tan inverse of, what is that, this is formula for tan of alpha minus theta, this is formula for tan of alpha minus theta, means this bracket becomes tan of alpha minus theta, and therefore what we will get, tan inverse and tan, it will get alpha minus theta as it is. And you know guys very well, so alpha minus theta is equal to what, alpha means here tan inverse of p by q minus here tan inverse of theta means here x, and you will now very well getting here. I am writing here, so that is tan inverse of p divided by q minus, you know, the series expansion of tan inverse of x. So let's see what is series expansion of tan inverse of x. So you have to use this formula, guys. You have to use this formula for series expansion of tan inverse x. So let me introduce here tan inverse of x formula. So this is nothing but this is x minus x cube upon 3 plus x raised to 5 upon 5 minus and so on. So this is what, by using method of substitution, guys. So in this way we have to expand some function by using method of substitution. So I hope you have to understand this concept very well, that is expansion by using method of substitution. Thank you.